Hello there, welcome to my presentation over stainless steel. To start off, I'll talk about the history of stainless steel, its material properties, how it's made, and then also the uses of stainless steel. So to start off with history, stainless steel was first discovered in 1913 by a man named Harvey Blain. Blain was a British researcher who was focused on trying to create gun barrels that were resistant to corrosion. He found that by adding chromium to iron, he was able to create an alloy that would not rust. And then if we hop into the future, in 1919, we began using stainless steel for our kitchenware, such as forks, knives, spoons, and also surgery scalpels. In 1930, in the 30s, we began to move towards transportation. So we had our first American train. It's called the Denver Zephyrs. And then in 1931, we went to the airplane. And then in 35, we transitioned to our sinks. So most of our sinks and kitchenware material were being made out of stainless steel. And then in 1954, we had the first underwater camera that was surrounded by stainless steels. And in the 1980s, this is a picture of the River of Thames. We were using stainless steel as a form of a barrier to prevent flooding from causing damage to the city. And then today, or the 2020s, we are still using stainless steel for all the previous things mentioned, but now we're also adding it more into the automotive industry along with architecture. So transitioning from our history of stainless steel, I would now like to talk about how the chemical properties of stainless steel affects it. So to start off, I have a definition. An alloy is a metal made by combining two or more metallic elements. So for stainless steel, it is primarily iron and chromium, and with a little 1% of carbon. So its alloys are iron, or it's an alloy that's created by iron, chromium, carbon, nickel, molybdenum, niobium, and manganese. And then I would like to talk about the crystal structures of stainless steel. So the crystal structure of stainless steel is dependent on the type of family. So there's 5 families, which are the austenitic, the ferritic, martensitic, duplex, and the precipitation families. But primarily only 2 of the families are dominant. So the austenitic family has an FCC crystal structure, and that family is about 2/3 of the rest of the families. The ferritic is a body-centered cubic crystal structure, and it's roughly the rest of the third. It's about 30%. And these 2 things are important, as knowing the crystal structure, it helps you determine the physical properties of the material and allows the differences in families to actually occur. Up next, we have the mechanical properties of stainless steel. So if we look at the right hand side of the PowerPoint, we have a stress strain curve of stainless steel, high strength steel, carbon steel, and aluminum. So to start off, I'd like to talk about the elastic modulus, which is also known as Young's modulus, or also the modulus of elasticity, and that is roughly 200 gigapascals. Moving on, I'd like to talk about the tensile strength of stainless steel, which is about 515 megapascals. The tensile strength is the resistance of the material breaking under tension. Up next, we'd have the yield strength, which is about 205 megapascals, which is the stress at which a specific amount of plastic deformation is occurring. So it would be occurring after the Young's modulus. And then after that, I'd like to talk about the specific heat capacity of stainless steel, as the CP, or the specific heat capacity, is the material's ability to absorb heat from the external surroundings. So for stainless steel, it's about 502 joules per kilogram times degrees Kelvin, whereas aluminum is about 990. So this is one main reason why we end up actually using stainless steel to cook food versus using aluminum, as the heat transfer is much easier, or it doesn't require as much energy to transfer the heat from the stove or oven, wherever you're cooking, to your food. So then up next, I'd like to talk about the toughness. The toughness is the ability to absorb energy and plastically deform without fracturing. And the toughness for stainless steel is about 120 megapascals. And then lastly, I'd like to talk about the shear modulus, which is just the ratio of shear stress to shear strain, which is about 77.2 gigapascals. So to create stainless steel, it's rather simple. You just gather your raw materials, you melt them, and then you remove the excess carbon, and then you end up tuning the molten steel, checking for quality, and then you let it cool, and then you can shape it to your final product. But essentially, this just telling you these steps, you don't really get a good grasp of what actually is happening. So I have about a 3-minute video that we're going to watch at 2 times speed. So it'll be 3 minutes, but it'll show the process a lot better than what I described. So now I'm going to start the video, 2 times speed it, and hopefully you guys, it'll update while we're watching. So send it 2 times speed and play, and play. I'm going to turn subtitles on in case you want to read. But essentially, I'll try to explain what's happening as well. So here they're just melting the metals, or the scraps. So the first step. And now they put it in a oxidized decarburization vessel, and this is to remove the excess carbon. Step 2. And then step 3 is right here. They have now formed it into a metal bar. They clean it off from the dirty chemicals, they form it again, they send it, they cut it, and then they just keep cutting and keep processing it essentially until it gets to the bars, then they smooth it out, straightened and polished, and then lastly they are sent out and they are dried in the sun for a few weeks. And then they get onto the truck and the truck ships them to wherever they need to go. So now that we know how it's made, I'd like to talk about some of the uses of stainless steel. So to start off, I'd like to say that stainless steel is an extremely valuable material. It's recyclable, and it's also resistant to corrosion, which is important for many things, such as like in the restaurant industry, our sinks and grills. So since it's resistant to corrosion, that means no matter the grease that is that comes from our food, it's easily cleanable. For cars, in the picture in the top right, we have a car that's completely made out of stainless steel, but you don't see that anymore as it's not cost efficient, as well as it's a pretty heavy car. Versus cars now today, they only use the stainless steel for the exhaust, the outer panels, trips, and engines. Basically, the parts that deal with chemicals and heat would deal with the stainless steel, whereas the rest of the body is usually made out of plastics due to its cheapness. And then in factories and plants, I don't know if my picture's covering it, but I have a tank there, and in that tank there would be dirty chemicals, water, whatever, you can name it. So stainless steel is a clear choice of why we'd want that, since it is resistant to corrosion. And if you ended up getting a hole in your tank, that is not good, as it would cause shutdown in the factory. And then lastly, I'd like to just say that now, today, we're starting to even transition to having stainless steel in our luxury watches and our premium smartphones. Just a little bit, not enough, not the whole thing obviously, but just a little bit, as it's, again, resistance to corrosion, and it's also like a clean look. If you look at the steel car, it's kind of a minimalist approach, sort of, and that's kind of how a lot of our society is trending towards. So here's my references that I ended up using. Like I said, just a brief overview. I think stainless steel is an excellent material. It's durable, it's resistant to corrosion, which is awesome. It's recyclable. Thus, I think that it's extremely important that we continue to use this material, and without it, I think we would be extremely set back in our technological advances. So I hope you enjoyed watching my presentation. Hopefully you learned a bit, or at least one thing, and thank you for listening.